Hello everyone, Namaste. So in this video we will be learning about linear regression and in particular linear regression in one variable. In the last introduction video we saw about supervised learning and unsupervised learning, and in supervised learning we had classification and regression. Regression means outputting or predicting from very large number of data or like infinite many numbers of data, continuous data. And in case of classification you have distinct finite number of data from where you predict. So let's see what linear regression is. So it's a fundamental machine learning algorithms used in predictive modeling. So what it does is you have one variable on x-axis, you have one variable on y-axis, and it fits a straight line, which can show you the relationship between the input and output. What do I mean? Suppose you take an example, you have input as house size and output as the price of that house. So you can see it's a linear dependent variable. If you have very small house, then the price of the house will be less, but as you can see in general, if the size of the house increase, the price of the house increase as well. So you can say this is a linear relation. Same thing here, hours spent studying, if you study for more, your exam final score will be much greater. And same thing here in advertising budget, if it's very high, then the product sales will also be high. So the input we generally denote it by x and the output we generally denote it by y. And x is independent variable because we can put any number in the x and it doesn't depend on anything, but in case of y it depends on x. So that is your dependent variable and x is your independent variable, and x is on x-axis and y we put it on y-axis. So let's see. So this is that line which I was saying. So in maths or calculus or your coordinate geometry, you might have seen y equals to mx plus c equation, which represents a line. So if you see here, what does this c means? C is your y-intercept, means where the line is cutting the y-axis. So if you just put 0, 1, 2, 3 something, the line is cutting the y-axis at 1. So how do you find it? As you can see, the x is here, y is here, x is 0 here. So you just put x as 0 here. So this whole term becomes 0, and you are remaining with y equals to c. And whatever the value is of c at this point, x equals to 0, it is your c. So y equals to 1 will be your y-intercept if the value of x is 0. So what we do is you put one thing on x-axis, like in our previous example we had size of the house on x-axis and price of the house on y-axis. You plot those things which you'll be having the data of, and you try to fit a line among this line should be as nearer to these points, or in other words you can say the distance between this line and each of these things should be very minimal. So we'll see how this works. So you can see here this f function which depends on w and b equals to wx plus b. So if you just change the things like slope, w is your slope and b is your y-intercept, as we discussed previously. If the slope is 0, then you can say that the line is just parallel to x-axis. See, this is slope 0, but if your slope is 1, then you can see that 45 degrees it extends to both the x-axis as well as the y-axis. So this is slope 1, and you can see here the line is cutting it at if the x is 0, then it is cutting it at 1. So that's why intercept is 1. You can change the intercept. If you can move, see it's 5, so you can see it's cutting here at 5. Same way if you go negative, I don't have the negative one here, but it will be similar thing. If it's -1, then on x-axis it will be cutting -1. Same thing for that. So you can change w and b to change the orientation of line, and you can put this line anywhere in the 2D plane. This is how this function works. Now, as I mentioned there, that after you have put everything, so this was your size of the house and this was your price of the house, and you have multiple examples. Suppose we take Bangalore, which is a city in India. Size of the house was suppose 100 square feet, let's say example, then 200 square feet, and the price was again something 10K. In India we use rupees, so it's in rupees. 20K, then 30K, then size increases, then this one increases. So you try to form a line which is nearer to all the things. You try to cross it, but you won't be able to cross it ever, because the points might be like this. So there can't be a line going among this is entire line, straight line. So then you try to, on x-axis you can take a point, and then you can see that how much this point is far away from the predicted value. This line predicts, this is a prediction line, so this predicts. So what you need to do is you need to take the actual value, this is the actual value, and this will be your predicted value for the x value of this. Suppose x was 25 something, x was 25. So for x, you see how much was the predicted value on this line, which you will get by taking the corresponding point on y-axis, and this value also you will get by taking the corresponding point on y-axis. And whatever the difference is, 30,000, and let's say suppose it's 18,000 something, so 30,000 minus 18,000, 12,000 is your error. So that is how error is calculated. So you can see here the error in this case is -4, because the predicted value was here, which is your 2, and the actual value was 6. So predicted value was 2 and the actual value was 6. So 2 minus 6 becomes -4, which is your error in this case. So that's how error is calculated. So now let's move to different slide. So we have some of the common error metrics. So you might have heard about these things. What exactly MAE? We will discuss this just right now. So we already know what error is. Error was predicted minus actual, right? Predicted value minus actual value. In that case, it was 2 minus 6, which was -4. Now, there are some standard formulas which people use. How to remember this? I'll tell. So this is MAE. Let's say how MAE is defined. MAE means mean absolute error. In this case, you just need to read it opposite in the reverse direction. So start with the error. Just write the error first. So it is P minus A. Then absolute. Absolute is nothing but taking an absolute function. So absolute of -2 becomes 2. It's just modulus. So -2 plus 3, if you take absolute, this becomes 3 minus 2 is anyways 1, but absolute of 1 is again 1. So any negative values, it becomes 1 and positive. The modulus function, it's a function like this, which is always positive. In if the x is negative, it is again positive, the y is positive, and if the x is positive, it's anyways positive. So we'll start with this. As I said, we need to read from the reverse direction. So error. So error was predicted minus actual. You take the absolute and find the mean of it. We had there will be many dots or the points. So we take those points as m. So in this case, you'll sum it like for each m. What I meant to say is this. So there are 4 m. So 1, 2, 3, 4. This minus this minus this minus this minus this. So that's why we are summing it here from 1 to m. So I equals to 1 to 4 in this case, if we take this. So 1 to 4, and there is something called as 1 by m, because we need to take mean also. So that's why mean is nothing but average, and it's summation of anything upon the number of those values. If you have studied mean or average, finding average. So that's why we are taking 1 by m here. That's the mean. So this is how mean absolute error is calculated. Same way for mean squared error. If you just write it in opposite direction, which is your yi minus y hat, which is which is just a notation for writing your actual and predicted values. This is predicted value and this is actual value. And you found the error. Let's start from the reverse. You found the error, then you need to square it. So here is square term. So just square it. and then you need to find mean. So just find the mean. The mean is nothing but average sum of all the points and taking the mean. But in our case, when we take mean average error or mean squared error, we introduce a term 2, which will see in later videos why we do that. It's just for making our calculation easy, but it doesn't affect anything else. So that's how mean squared error is calculated. So r squared, let's see what exactly r squared is. Let's delete this. So r squared is, suppose you have all these data points and you don't know what linear regression is or whatever it is. So the best bet which you can take it, just take the average of these values. What exactly are the average of these values? And you'll say, okay, so I had 100, I had 200, I had 300, and I had 400. So the average value of the other things will be the average of these values. So that's how you will deal with that if you don't have any model or the knowledge of anything else. So R squared basically, it tells that after creating a linear regression model, how much of the change or the variance was there when you created this linear regression model compared to which you had the average, just this normal. So comparison between this method and your linear regression method, that's what r squared tells you. So as you can see, if r squared is very low, like suppose if it is 1, then your model is predicting perfectly, because this term, the this one becomes 0. This one adds the denominator, you can see it's average, and the numerator it's saying predicted. So it becomes 1 minus 0, it will be 1. So model is predicting perfectly. And if this term is equals to the numerator is equals to the denominator, it means that the average one and the predicted values both are same, and hence this becomes 1. Like this one is 1, this one is, I mean, exactly whatever it is. Like suppose this is 2.5, this below one is 2.5, this one is also 2.5, and both get cuts and it become 1. So 1 minus 1 equals to 0. So that's why this is how r squared works. So let's move. Now let's move to cost function. What exactly is cost function? So you saw error, right? Mean average error or mean squared error. Let's take mean squared error. So in this case of mean squared error, what was happening was, you know this term, right? This is you had this f of wb of x equals to wx plus b, right? And if you just put x here, the x value here, and you had this line, right? So this point will give you the predicted value. So this becomes your y hat. This is your y hat, and you have some ground truth or the real value, which is your y. So if you put x here and this line is this, so this will give you y hat. So you can write this as y hat equals to wx plus b if you put x value here. So that's why in case of error you had this y hat minus y cos square and all. So instead of y hat, you can just replace it with this function f of x. So that's what we are doing. F of x minus y remains as it is, and then square, you have the summation. And as I was saying, there is a term of 2 which makes it easier for calculation in later upcoming things. So this is a cost function. What exactly is cost function? Error is basically for one thing. So suppose you calculated this was your error, but if you just sum it all, it becomes a cost function. So we just give it a name as cost function. It is a type of error only. So what exactly we need to do? If it is just a error function, we need to minimize error, right? To get maximum accuracy, you will try that, okay, my error should be very minimal. That means if you have suppose two lines, 2 points, you draw a line, then there will be some error, right? But if you just move that line to here, there is some minor error. So suppose this was 1 and this was 5, so this there are 6 here. This becomes very very less, 0.5 1, so this becomes 1 1.5. Now if you make this line crossing through both the points exactly, then the error will be 0. So your thing should be passing the line to all the points, but you'll say okay exactly, then every time we'll pass the line through the points, but every time you won't have only two values, right? There will be multiple values like this, like this, like this, like this. For a 1x you can't have two values. This is slightly here and this is slightly here, so you can't pass a straight line from all these points. That's why you try to minimize this error. So that's why cost function, you just write this as cost function and you try to minimize the cost function. We'll see how we will do that, but for now you can see this is called a cost function. Now we will visualize the cost function. You can see there is a square term here, and if you know from your calculus the y equals to x square graph, it is somewhat like this. How it is drawn? For just put x as 0, you'll get 0. Just put x as 1, you'll get y as 1. So x as 1, y as 1. Just put x as 2, you'll get y as 4. So 2 4. Put x as -1, you'll get again 1. Put -2, you'll get 4 again. So like this. So this is x square graph, and that's why the previous one was like that. So the thing is, in case of our cost function, it depends on b and w both. So we will visualize this in 3D plane. So this is like this. You have w here, you have b here. This is suppose x, this is y, and then you have one more axis coming out, which is normal or perpendicular to both b and w or bw plane. This is called cost function. So let's denote it by j. So if you draw this, it will be like this bowl. If you eat something in a bowl, it is like this, and you have to minimize the cost. So this bowl can be either this way or this way, depends. Anything is possible. If you are seeing from here, then it is minimizing here. You are seeing from here, again a different thing. So what you need to do is you need to find the minimum. As discussed in the previous slide, you need to minimize the cost function. So you need to find the minimum, and how you will find the minimum, we will discuss that in the next slide. There is a better visualization which will help you to find the minimum cost. So let's see how it is in the next slide. Yeah, so suppose these are your points. Okay, these 1 2 3 4 5, this is size and this is price. So as you can see, the line is not currently matching these points, and it won't exactly match, but we will try to put this close as possible. And here you can also see the cost function which we are discussing, wb. Let's say this is w and this is b, and there is one more line which is coming out of your screen, which we can't see, but for example let's make it like this, j. It is coming out of your screen, but this is 2D, I can't draw that, but yeah, this is coming out of your screen. So you can see this orange thing, it means the line is very very up towards your screen, and this greenish color, it means the line is, or the points are away from you. So it's like a bowl, but you are seeing it from above, you're seeing it from top, and this is your orange color and this is your greenish color. This is your greenish color, this is your orange color. You're looking it from top. So let's see, if you move, suppose this, you can see we can change this. We are currently here, suppose we are currently here. Okay, let's suppose you're here. You need to move to this point to get the minimum and to change this line. So what you'll do, you'll reduce the intercept, you'll reduce the b. So if you had y equals to 5x plus 9, so what you'll do, you'll reduce this 9, it will become 5x plus 3 or something, and you will come down. Okay, and then you'll go left, you'll reduce your w, so you'll reduce this, so it becomes suppose 2x plus 3, and you'll reach this point which is minimum. Like you started from here, suppose you are starting from here, you go like this here, and then you go like this here. So to get that, but in general we change it simultaneously, so we go like this, like this, like this. So you change W and B at once. This was just for introduction or just for explanation, but you change both W and B simultaneously at once. The program does it. So it moves like this, like this, like this, like this. It reaches here somewhere. So let's try this. And you can also calculate cost function. So at this point, when your intercept is 50 and your slope is 100, the cost function will be this 1256. So let's try to move. If you just try to move this here, you can notice the line is also moving, and here the B is also moving on y-axis. See, the B is moving up and down, right? So you try to move this line till here. Okay, so you thought that this B is correct and this is the intercept which is good for you, but slope might be different for this. So you can see the line is changing its slope, and your this red point is also moving on the on here, and you can see you reached here, but you think the slope is correct, that if you draw a line it should be parallel to this, but it's away, it's very very away, so you need to bring that line down. So if you just try to bring that down, what you need to do, you need to change the intercept also. So you move this line closer to these points, so you can see the point in the here, the point red is also moving. So yeah, you'll find this, and if you move it somewhat here, you will see, okay, this whole area is green. You can take any number. You can see that this line is now closer to these points, and your cost function is also very very low. What was cost function? Cost function was nothing but all the sum, like 1 upon 2m and summation of all these points. Like this was the error. Like suppose this is 500, yeah, 500, and this is 520 or something. So 20, like 520 minus 500 is your 20, then squaring it, then again calculating for these two, everyone. So we calculate it for everything, then we sum it after squaring it, and then we take 1 upon 2m, which is your number of these points, 1 2 3 4 5 6 7 8. So 8, 1 upon 2 into 8, which is 16. So 1 upon 16, and then you put all the numbers and you calculate, you will get 69 as your cost function. So your work was to calculate the cost function and to minimize it to get the best values. So that's how linear regression works. So let's remove this. So there are three things to notice here. You can move these B and W to fit this manually. You can see B and W in that cost function, or you can do this. So if you just move intercept here, you can see cost function increases, and here if you move, cost function is decreasing. And you can move slope also to check if the cost function is increasing or decreasing. So that's how it is done. Next, now we can take one real life example of how it is done. So you can see Rohit, he wants to buy a house and he has some data like size, square feet, and price in rupees, which is lakhs. So 10 lakhs is 1 million if you see. So he has this data and he wants to predict how much will be 1500 square feet house. Like he wants to predict what will be the 1500 square feet price if you want to help. So let's do this in a real life scenario with taking an example. So in case of Python, you have some libraries which helps you, so you don't need to calculate it from scratch. So what are the libraries which I'm speaking about? It's sklearn or scikit-learn. So the code is from sklearn dot linear models. You can see the documentation. Don't use GPT or other models. You try to read it from documentation so you can understand much better. So import, there is one class which is linear regression. It helps you to get the linear regression class. I'll explain what exactly is happening. You also need to import one library which is your numpy library, which you might be knowing already. So you run it. Now let's write these things in an array. So np.array, because you already imported the array. Now one thing to notice here is you might have seen Excel sheets, right? So in Excel sheets, if you have just one column and you're sending it to someone else, then you are sending an Excel sheet with just one column. But if you're just sending if you're just copy pasting one single column and pasting it in a notebook or somewhere else and just sending it to someone, it's just one column. So understand the difference. We are sending one column in an Excel sheet, that is a data frame, and when you are sending one column in a text or something, that is called as your series. So that's why difference. Because in Excel sheet you can add columns, but in txt file it will be very very difficult to add columns or sort. So that's why. So whenever you write X, even if there is one column, you put everything in list of list or arrays of arrays. So let's put everything here 800, because in linear regression we basically have more than one column, so that's why. So 800, then you have your 1100, then 1250, then your 1600, 2000. I suggest you to not copy paste the code or anything. You need to write it from scratch on your own so that it gets imprinted in your brain. Because even a minor thing like why we use two arrays and not one single array, it helps a lot. That's why you can always copy it. It's not an issue, but I'll suggest it to write it from scratch in your notebook or wherever you are practicing. 42, 48, and whatever the next 60 and 75. So as I said, these are a list of list and this is just a list. So you got your x and y. X is on x axis and y is on y axis. So this was this. Now we need to call an object for, or create an instance or an object for the class linear regression. So we do it like this. You got an object of linear regression. Now what you will do, suppose you got one model or whatever a straight line you got, but the straight line is not yet trained with your data. It is not aware with x and y. So what you'll do, you will just write lr or the object instance name dot fit, and you pass x and y to it. So that now okay, we have an issue here, and the dot array doesn't works. Why? Let me figure this out. Wait. So basically, you can see the error is here. The linear regression is a class. So I was just copying the class to a new class. So it was just type of copying a class. So if to create an instance or an object, you need to mention it like this. Now just run these both codes, and now you can see that it has fitted. Like there was one instance created lr, but it doesn't know what's the good w or the b for the data we have. So that's why it fits it now. What you'll do now, you got the object to get fitted on your data, which is this data. So you'll try to predict it. So you'll take the object name, which is lr dot predict. Now what? You can see the syntax also, but I'll mention it here itself. You need to put an x value or multiple x values to predict it. So let's put one x value, but x is like this in double array. So you'll put x inside a nested loop, not loop, nested array. So we need to find for 1500 square feet. You just need to put 1500 here, 1500, and predict. So this is the one. If you need the item inside array, so you just need to write item. So 52.498, that should be your answer. So if you see, Rohit have to pay 52.498 lakhs for 1500 square feet. So now let's move to our question. So the same thing, if you just run it and see 56.57 exact value which we were having, and on the graph also you can see for 1500 thing the value will be somewhere here, which is your 1500, and the value will be like this, and it's online. So the predicted value is online. That's how it works. So congratulations, this was your linear regression in one variable. Some of the key takeaways were the model linear since it was linear, we considered the linear equation. We understood what exactly is cost function, and we needed to find w and b to minimize the cost function, or to find the lowest possible cost, or to minimize the error. Now in upcoming videos we'll understand what exactly is gradient descent, how multiple linear regression works, And polynomial regression, multiple linear regression means we'll be having multiple columns instead of one columns for your x. And polynomial regression, it means it won't be a straight line, it might be another x square, x cube, or another type of variable. So thank you very much. Do subscribe if you like this. Thank you very much.